Okay, guys, in this lesson, we're going to talk about our last rigid transformation called a rotation. So, a rotation is turned about a point, and for the most part, we are going to rotate about the origin. You can rotate counterclockwise or clockwise. So, clockwise is going to the right, and counterclockwise is going toward the left. Sometimes counterclockwise is known as the positive rotation and clockwise is the negative. So here are the rotation rules for counterclockwise. So we are going toward the left. So we're going to talk about three types of rotation, going counter, and then three types going clockwise. So we can rotate about the origin going 90 degrees. So this blue triangle is our pre-image, and notice it is rotated 90 degrees going counterclockwise. So 90 degrees is moving one quadrant around. So we started out in quadrant 1, and now we are in quadrant 2. So we can take a look at this ordered pair, which is 3, 5, and it's rotated going around the origin, and the new ordered pair is -5, 3. So you can see that the rule is when you're rotating counterclockwise 90 degrees, the x coordinate stays the same value, the y changes to their opposite, and then they swap positions. So the notation for the rule is -y, x. Now the negative doesn't mean that it's going to be a negative value. It just means it's going to change the sign of the original value to its opposite. So you change the value of the y, and then you switch the x and y coordinate position. So that is a rotation about the origin going 90 degrees counterclockwise. Then we're going to rotate counterclockwise going 180 degrees. So we have moved 2 quadrants around from quadrant 1 to quadrant 3. So we can notice again that we have 3, 5, and now we are here at -3, -5. So when you rotate 180, the x and y just changes to their opposite value, but they don't swap positions. Then we have 270 degrees, which is moving 3 quadrants around the origin. And we went from quadrant 1 all the way to quadrant 4. So we still have our 3, 5, and with a rotation counterclockwise, we are now at 5, -3. So when it's 270 degrees counterclockwise, the y value stays the same, but the x value changes to the opposite, and then they swap positions. So we have counterclockwise 90 degrees, 180, and 270. So now let's take a look at going clockwise. So we have rotating about the origin going 90 degrees clockwise. So this time we are going in this direction. So we're in quadrant 1, and now we're going to be in quadrant 4 going 90 degrees. So we have our reference point 3, 5. Now it is 5, -3. So you can see that the x changed to the opposite, and the y stayed the same, and then they switched positions. So this 90-degree rule for clockwise is the same rule as the 270 counterclockwise. So those match up. Then we have 180 going clockwise, and we're moving 2 quadrants around from 1 to 3. And our reference point 3, 5 is now -3, -5. So the rule is the same going clockwise or counterclockwise. The two values, the x and the y coordinate, they just change to their opposite sign, but they do not switch positions. Then we have 270 going clockwise, so that's moving around 3 quadrants. We're in quadrant 1 to quadrant 2. Our reference point, 3, 5, is now -5, 3. So the x stayed the same, the y changed to its opposite, that's what this negative means, and then they switched position. So the 270-degree rotation about the origin clockwise is the same rule as the 90 degrees counterclockwise. So when we can summarize these rules, and you can see that the counterclockwise 90 and the clockwise 270 are the same. So you can see that this rule going counterclockwise 90 or going clockwise 270 is the same rule. You can also see that the counterclockwise 270 and the clockwise 90 is the same rule. And then going halfway around, 180 going clockwise or counterclockwise, they have the same rule. So just remember 180 degrees, the two coordinates just change signs, but they don't change position. Okay, let's get started and do some practice. So here we have our pre-image is in quadrant 4. A is going to be 1, -2. B is 1, -6. And C is 5, -6. A prime is going to be 2, 1, 6, 1 is B prime, and C prime is 6, 5. So we went from quadrant 4 to quadrant 1 if we are going counterclockwise. So we're going to write the rule for counterclockwise unless otherwise noted. So we have a capital R for a rotation. We are rotating about the origin, so we have an O. And now, if we are going counterclockwise, we went 90 degrees. So when we went 90 degrees counterclockwise, the x stays the same, so the value stays the same. The y changes to the opposite, so this negative becomes a positive, and then you flip-flop the two coordinates. Okay, now again, we are in quadrant 4. We are going to go counterclockwise to quadrant 2. So we're going halfway around 180 degrees. So A is 1, -2. B is 1, -6. And C is 5, -6. So we are rotating around the origin and we're going 180 degrees. So 180 degrees means that the x and y do not switch positions. The values just change to the opposite. Uh-oh, we need a negative here on that one. So I know that all these x values are going to become negative. They're negated. And then we negate these negatives and they become positive. And to be in quadrant 2, we do need negative, positives. So we can check it out. -1, 2, -1, 6, and -5, 6. Okay, our third one, we're in quadrant 4 again. We're going counterclockwise, so we're going around until we end up in quadrant 3. And we're rotating about the origin. So our rotation is about the origin, and we're going 270 degrees counterclockwise. So sometimes you may see this for counterclockwise. So we have 1 comma negative 2 again for A, 1 comma negative 6 for B, and 5 comma negative 6 for C. So if we're going 270 counterclockwise, this time the x's change to their opposite, and then we flip-flop positions. So these x's all become negative, and they go in the y position. So -1, -1, -5. Then the y values stay what they are. They just move to the x spot. And we do need negative negatives to end in quadrant 3, so we can check it out. So A prime, -2, 1, B prime, -6, -1, and C prime, -6, -5. Okay, now they are giving us the rule, and we are going to identify our pre-image coordinates. So we have 1 comma -2, 1 comma -4, and we have 6 comma -4. Since we are going counterclockwise, so we're going counterclockwise, we're going around all the way until we get to quadrant 3 because 270 is 3 quadrants. So since we are moving 270 counterclockwise, the x values change to the opposite and move to the y location. And then the y's stay the same value, they just move to the x location. So we have -2, -1 is A prime, -4, -1 is B prime, and -4, -6 is C prime. And then here is what the triangle looks like. And again, we've rotated about the origin. So it's turning all the way around. Okay, we're going 180. We are starting in quadrant 1. We're going to go to quadrant 3 because we're going 180. It doesn't matter if we're going counterclockwise or clockwise. We have the exact same rule. We end up in quadrant 3. So A is 3, 7. B is 3, 3. C is 5, 3. And now we're just going to negate everything, and the x and y coordinates stay where they are. They just change to the opposite. So we have -3, -7, and that is A prime. And then we have -3, -3, that is B prime. And then -5, -3 is C prime. And again, connect your vertices to create the triangle. We're starting in quadrant 4, and we are rotating 90 degrees. We're going to go counterclockwise about the origin. And so A is 4, -2. B is 4, -6. And C is 6, -6. So when you rotate 90 counter, the x's stay the same. They just move to the opposite spot. So I have 4, 4, and 6. The y's change to their opposite value, and they move to the x location. And we did need, whoops, that's supposed to be positive. We did need all positive values because we're moving to quadrant 1. So we have 2, 4. So this is A prime. B prime is 6, 4. And C prime is 6, 6. And then here is our triangle. So here we go. We have a value, our x coordinate at 5, -3. We are going 90 degrees counterclockwise. So the x stays what it is. And we are going to change the y to its opposite and switch their location. So 3, 5. So we started it in quadrant 4. We went 90 degrees and ended in quadrant 1. We are in quadrant 2 for the Y point, we're going 180, which is halfway around, so 2 quadrants around. The two values are going to change to their opposite, but they're going to stay where they are. And then this puts us at quadrant 4. And then point Z, we're going 270 degrees around the origin. Z starts in quadrant 4. We're going all the way around, so we will end in quadrant 3, where everything needs to be negative. So going 270, the x's change to their opposite, the y's stay the same value, and then they flip-flop. So this is going to be -4, -1, which does give us a coordinate in quadrant 3. Okay, now we're going to write the rule. So we're always going to go about the origin. So that's an O for the origin. And so we have changed positions and the x has changed. Oh, excuse me, yeah, the x has changed value, and so it went negative, and then they swapped positions. So this is going to be 270 degrees about the origin. On our next one, they've switched positions, so we know it's a 90 or a 270, and it's the x remained negative, the y changed to the opposite, so that is 90 degrees counterclockwise. So I'm going to write counterclockwise on these. And then we have 9, -4 to -9, 4. The values stayed where they are. They just changed to their opposite. So that is 180 degrees. And I hope this helps.